A01 is going to allow us to prepare the ground for the remaining exercises of this module. We are going to have a task that is a very easy program to write. If you encounter difficulties writing this program, you need to absolutely contact me or the TA. Actually, me and the TA probably would be best to book a couple of sessions because this is very much a review exercise, nothing difficult, okay, just a little bit of C syntax, just a bunch of printf on the screen. So if you encounter difficulty, we need to identify them as early as possible so that we have time to intervene a little before the exam. So we have 4 files. This is very much preparatory work for the rest of the exercise. We have 4 files which we are going to use for the other exercises in this series. Uh, as is indicated here, tools.c, tools.h are going to allow us to host, respectively, the implementation and the declaration, the prototypes of the functions we are going to write in the following exercise. Main.c is going to allow us to offer an interactive menu to the user and allow the user to call our functions. And test.c is going to call also the function defined in tools.c and tools.h, but in a non-interactive manner, allowing us to pretty much test those functions, as I'm going to explain in the next couple of assignments. A02.doc, A03.doc, etc. Okay, so because you have a main function here and you will have a main function here, you cannot compile all those files together. So you have here a little couple of indication about how you can compile these files to generate 2 different types of executable. One that is going to be menu driven and interact with the user, one that is just going to run a bunch of tests and display on the screen a message only if one of the tests fails. Okay, so in the work to do section, you see what you need to fill as basic pattern in basic code in the files, and you have here the description of the menu of this application. So pretty much the main function in the main.c file is going to handle 2 local variables, x and y, initialize them to 0, and every time we display the menu, we display the current value of x and y. And then we offer a couple of choices to the user, depending on what they want to do on those variables. The display of the menu and the value of x and y is done by a function that is inside of the main.c file. Okay, so it's not part of the function we are going to implement in tools.c, tools.h. And you see that we have a certain level of error handlings. If the choice of the user is invalid, we display a message. If the user tried to call one of the functions that we didn't write yet, we display function not yet implemented, etc., etc. So we're going to do something different also this time as far as the video goes. Since the exercise is extremely simple, I'm just going to run you through the solution for this time. Okay, I'm still asking you to implement it from scratch on your own. So if you didn't do so yet, it's time to pause the video and go back to work. Otherwise, if you tried and you have problem, etc., I'm going to run you through one example of how you could implement this. So let's start by the main.c. So the main.c is going to be using all the function implemented in tools.c and which prototype is in tools.h. So I include stdio because I want to be able to do some printf scanf. I include also tools.h and notice the double quotes here, meaning that this is a local file in my current directory. Here is a prototype of my function display menu. Here is my main, and here is the implementation of display menu. So let's have a look at this. It's really trivial. Display menu takes 2 parameters, a value for x, a value for y, and display them as part of the menu. And the rest is just a bunch of printf. So really nothing difficult there. Back to the main. I declare x, y, my local variable, initialized to 0, and a variable choice, which is going to allow me to read a number from the user corresponding to a choice in the menu. I start my do while loop here. As you can see, I chose to make it an infinite loop, but I will make sure that inside of the body of the loop, I have a condition which trigger exiting the loop through a break statement, or as you can see here, through a return statement, which is going to cause me to return from the main, which means stop my application. Inside the loop, I display the information about my menu, passing the value, the current value of x and y, prompt the user for a choice, scan an integer which represents that choice, and then I do a switch statement to direct execution of my code depending on that choice. Choice 0 means I want to exit the application. Return from the main with value 0. That's fine. Case 1 means I want to change the value, the current value of x and y. Okay, prompt the user for a new value for x, prompt him or her for a new value for y, break out of the switch. Here, I didn't need to break out of the switch. Why? If you're not sure about this, pose the question in the forum, okay? But think about it. Case 2, case 3, case 4, I'm using the property of the switch statement which can cascade cases. As soon as I enter one of those cases, I'm going to execute this code. Printf, the function is not yet implemented, and break. Of course, in the next exercise, I'm going to progressively implement those functions. So I'm going to add here every bit of code I need to call them, test them, etc. And default, printf invalid choices, and then we'll loop again, display the menu again. So if you don't understand why there is not a break here after the default, same thing. Post in the forum, it's worth you thinking about it for 5 minutes, and if you really cannot figure it out, then ask for help, and somebody will jump in and explain to you, or I will do it. Okay, we're pretty much done with the main.c. Let's go to the next file, test.c. Include stdio. We need to do a printf at least every time one of our tests is not working. Pan include tools.h, double quotes, empty main, that's boilerplate code. Tools.c is where we are going to implement the function described in exercises A02 and above. For now, as indicated in the assignment, I just include tools.h. And then tools.h itself. As you can see here, we have something new, which I'm going to ask you to use as a recipe. So let me first describe the recipe. Every time you have a header file, you are going to use a precompilation directive if and def, which stands for if not defined. And you are going to follow it by a symbol. The symbol will be uppercase. We'll start with an underscore and with an underscore, and it will be the name of your file. Tools, the name of your file, sorry, tools underscore again h. After that, you will define a symbol. The symbol will be exactly the same name, and you will end by a pound and if, which clause is actually the pound if and def statement. So this is going to be between here, line 3 and line 7, this is going to be where your header code goes. And everything in your header file will be encapsulated inside of this one pound if and def, pound and if statement. Okay, now I'm going to ask this, I'm asking you to use this as a recipe for now. Okay, if your file is named mytools.h, then this would become mytools uppercase underscore h. Okay, so we have a basic understanding of what we need to do. Now, why do we do it? Well, this mechanism here, this little recipe, is meant to prevent multiple inclusion of a header file. And I think the best way I can explain that is by actually taking a sheet of paper and explaining to you what happens when you multiply include a header file. So here we go. All right, so let's take the example that we have right now with our code. This here will represent tools.h, our file. We have a pound, if, and def statement with a symbol. I don't really care about the name of that symbol. It's underscore tools underscore h underscore, doesn't matter. Then we have pound define, the same symbol, pound and if. Let's say that this here in the middle is going to be the code that I will have eventually in this header file. Okay, now let's take another file. Let's take the example of main.c. Inside of main.c, let's say that I have a pound include, double quote, tools.h, double quote. Okay, you already know what happened when you have a pound include like this, right? The precompiler is going to take this line, and replace it by what? By the content of the file you are trying to include. So this will be gone, sorry, and the single line will be replaced by pound if and def symbol, pound define symbol, the code that is in my header file, pound and if. And that's it. The single line has been replaced by all of that. Now if I have another pound include tools.h, well, the precompiler keeps doing its job, takes this precompilation directive, remove it, and replaces it by the content of the file that was specified. That is, in my case, the content of tools.h. If and def symbol, define symbol, pound and diff symbol. And this is the content of my file here. So let's say that I have a main with only 2 pound include like that of the same header file tools.h. Well, what's happening here? Anything I have defined here, function prototype, constant, global variable, is going to clash because it's going to be defined one time here, a second time here. So when I compile this file, if I was not using this pound, if and def, etc. mechanism, I would try to declare twice everything that is in tools.h, and that would not quite work. So instead of that, what the pound if and def directive does is test something. Test if a given symbol here is not defined. Well, the first time the precompiler runs through this file, okay, the precompiler is going to include tools.h here, and it's going to check immediately if the symbol here is not defined. Well, this symbol here, I made it up, okay? The name of the symbol is based on the name of my file to make sure it's unique in my entire application, and I made it up. I added some underscores around it, etc. So nobody defined it elsewhere in the code. That's the main thing. Because of that, if not defined and symbol name is going to be true. Because it is true, the precompiler allows to proceed to the next statement, which is pound define that symbol, which means define that symbol. So somewhere, the precompiler is taking note that the tools underscore h underscore symbol has been defined here. And then this code here is included. So this is a result of my first pound include. Second pound include, I'm trying to include again tools.h. If and def the symbol. Let me check. The symbol has been already defined. So if not defined, the symbol is false. Because this is false, the precompiler is going to skip everything until the end if, which means concretely, none of this here has been included in main.c. And this is how you avoid multiple inclusion of a header file. Okay, this is a very, very well-known and well-used trick. Okay, back to our code. This is exactly what we did here. Okay, and this is actually the only piece of code here that is not really trivial. This is something that I didn't expected you to come up with by yourself, so this is why I explain it in the video. But everything else in this code is really trivial. Now, what I will ask you to do is, like in any exercise, you have a test on S here. Well, you are going to play with it, and you are going to try to test your code. So testing your code means trying option 0 of the menu, option 1, option 2, option 3, option 4. That's pretty much it. You will have to fill in here what you expect. Okay, so for example, in option 0, you expect exiting the application. Okay, option 1, you expect change values of x and y. See it on next menu display. And then, etc., etc. Here you expect a message that is function not yet implemented, and you will have to test also an out of range value in which case you expect message invalid option or invalid choice. Please try again. And here, function not yet implemented. And this is going to be the same thing for number 3 here and number 4. So when you do your test on sometimes you expect just numerical results. Okay, sometimes you just expect the program to behave a certain way. This is what you will write down here in this test on S. So now that we have this test on S, let's go and try to compile our program. So two ways to compile it. Compiles tools.c along with main.c, which gives us the interactive version of our program. Or I can compile tools.c with test.c, which is going to give us the test version of our program. Right now, I don't have anything in the test, as you saw. Okay, it's because I didn't write any of the function which will be described in A02, A03, A04, A05, etc. So right now, I'm just testing my menu, and that's it. So I'm going to go back to compile tools.c and main.c. So every time you do one of the over, you regenerate a a.out executable. Okay, so they overwrite one another. I'm running my program here. Display of the initial value of x and y is correct. Well, let's try to exit the application. 0. Works. Let's try to set new value for x and y. 3 and 9. 3 and 9 are displayed here, so the current value have been changed. It works. Let me go back to my test on S. So 0 works, 1 works, 2, 3, 4, 5. Alright, let's go back here. I'm going to try 2. And you can see here, function not yet, not yet implemented. Besides this, hold on a second. Okay, function not yet implemented, then 3. Same thing here. 4. Same thing again. Error message is there. 5. Invalid choice. Let's try again. So we are handling our error situation pretty good. Okay, 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 and okay. Test on S is complete. So I'm going to go back to the code of main.c, just put it on the screen, and we are done with this exercise.